Alright, so this is our last video for the semester. It's over sections 7.3 and 7.4, solving by elimination. Your book calls it linear combination, and they actually do these problems by using addition and subtraction. But I think it's easier for us if we just do one method, so I like to teach using the addition method. So here are our steps for elimination. First thing we're going to do is we're going to check for standard form. Every now and then when you come across problems, they are not going to be in the proper order. And that's got to be the first thing that you do, is make sure that your two equations are in the same order. So we're always going to check for ax plus by equal to c. And when we look at that standard form, we're really looking to see whether or not they're in the same order. We're not worried about fractions or negatives the way that standard form is. Remember that ax plus by equal to c, that it has those two rules, that there are no fractions allowed and a has to be positive. That rule doesn't apply here. It's just about order when we talk here. So most of the time, that first piece we won't have to worry about, but it's something we should always keep in the back of our head. The second thing that we're doing, and well, really the first step to elimination, is that we need to make either the x or the y terms additive inverses. Remember that phrase additive inverses just means that they have to add to 0. So think about things that would add to 0 in terms of x and y. If you had negative 4x and positive 4x, they would add to 0. Or if I had 3y and, oops, not divided, I want to do 3y and I also want to do negative 3y. I don't want that divide sign in there. It's not really there. Because positive 3y plus negative 3y, they add up to 0. Now this isn't always going to happen. We're going to talk about how to make that happen as we go through our example problems. The second step is going to be add the two equations together. And step 3 is going to be find the solution. Remember that in chapter 7, we have 3 types of solutions. We could have no solutions. So we'll have a false statement, something that doesn't work. We could have infinitely many solutions. We write it this way, meaning that all of the points are the same. So whatever point we get for one will always be on the other, because they're the exact same line, written 2 different ways. Or, and this is the most common version, that we're going to have one solution, where we have an ordered pair, where we get an x value and a y value. One solution. Remember that in terms of picture, that's telling us that our 2 lines intersect, and this point is the one that they share. It's their common point, the idea of being a solution or satisfies both lines. Infinitely many solutions in terms of picture is the same line on top of it, and no solutions would be 2 parallel lines, lines that never touch. So let's start with problem number 1. Check for the order. ax plus by equal to a number. ax plus by equal to a number. Good, my order's fine. So really the first step is check to see if you have x's that add to 0 or y's that add to 0. In this problem we have y values. Positive 2y and negative 2y add to 0. So if those two add to 0, they are additive inverses, then I can take the 2 equations and I can add them together. When I do that, 2x plus 3x gives me 5x. 2y and negative 2y, well, that makes a 0. So that's going to eliminate y for me, equal to negative 2 plus 12 is 10. So I'm now looking at 5x is equal to 10. Divide both sides by 5, and I end up with x is equal to 2. Remember that x equal to a number isn't enough. in order to have a solution, I need to have an ordered pair. So I take my x value back into either of my problems where I have both x and y, and I solve for the other variable. I think the first equation looks easier, so that's the one I'm going to choose. So I'm going to do 2 times my x value, that's 2, plus 2y equals negative 2. All those 2's. Now I'm solving for y. 2 times 2 is 4, plus 2y equals negative 2. Subtract 4 from both sides so that 2y is equal to negative 6. Divide both sides by 2 so that we get y is equal to negative 3. And my solution, my one solution, the point where the two lines intersect is the point 2, negative 3. I have a feeling that this makes sense, so I'd like you to pause the video and try number 2 and see how you do. Mean it, pause it. All right. Hopefully you're back and you're ready to take a look at this. We're just looking to see what do you get. Hopefully this time you saw that 4x and negative 4x add to 0. They are additive inverses. So we add them together. They make 0, adding the whole equation. Go back and plug this in anywhere there is both an x and y. Again, hopefully number 2 worked out just fine and you're doing good.